Lead. It's a heavy metal, literally. But it's also been a heavyweight in human history for thousands of years. From ancient plumbing to modern batteries, this versatile element has played a vital role in our development. This essay takes you on the journey of lead, from the mines where it's extracted to the recycling plants that give it new life. We'll explore how it's used and the environmental challenges it poses. Lead isn't found lying around in its pure form. It's usually stuck in rocks called ores. The most common lead ore is galena, which has a distinctive metallic shine. Miners extract these ores from the earth, often in challenging underground conditions. They use heavy machinery to dig deep shafts and tunnels, following the veins of ore wherever they lead. Mining is tough, dirty work, but it's the crucial first step in lead's journey. Once the lead ore is out of the ground, the journey to transform it into usable lead begins. This process is intricate and involves several stages, each crucial to ensure the purity and quality of the final product. Initially, the extracted ore is transported to a processing plant. Here, the ore undergoes a series of crushing and grinding operations to reduce it to smaller, more manageable pieces. This is essential to facilitate the extraction of lead. This crushed ore is then sent to a facility known as a smelter. The smelter is a highly specialized industrial plant designed to handle the intense heat and chemical reactions required to extract pure lead from the ore. At the smelter, the ore is subjected to further crushing to ensure it is fine enough for the next stage. It is then heated to extremely high temperatures in a furnace. This heating process is critical as it causes the lead to separate from other materials in the ore. The intense heat in the furnace forces the lead to melt and separate from the rock and other impurities. This molten lead is then collected, while the remaining waste material, known as slag, is removed. Slag is a byproduct of the smelting process and consists of various impurities that were present in the ore. It is typically discarded or repurposed for other industrial uses. The purified molten lead is then carefully poured into molds. These molds are designed to shape the lead into blocks, known as ingots. As the molten lead cools and solidifies, it takes on the form of these molds. Once the lead has cooled and solidified into ingots, they are ready for the next phase. These ingots are stacked and prepared for shipping. They will be transported to various manufacturing facilities where they will be transformed into a wide range of products, from batteries to radiation-shielding materials. Lead's unique properties make it incredibly useful in a wide range of applications. One of its most well-known uses is in car batteries. Lead-acid batteries are reliable and rechargeable, making them essential for starting vehicles. Lead is also an excellent shield against radiation, so it's used in hospitals and nuclear power plants to protect people from harmful rays. Additionally, lead is a dense and malleable metal, making it ideal for construction materials like pipes, roofing, and soundproofing. While lead has numerous benefits, it's crucial to acknowledge its downsides. Lead is toxic to humans, especially children. Exposure to lead can cause developmental problems, learning disabilities, and other health issues. This is why lead paint is banned in many countries, and there are strict regulations for handling lead products. Furthermore, mining and smelting lead can release harmful pollutants into the environment, contaminating air, water, and soil. Closing the loop. The importance of lead recycling. Given the environmental and health concerns associated with lead, recycling becomes paramount. Recycling lead not only conserves natural resources, but also reduces the demand for new lead mining, minimizing its environmental impact. Furthermore, recycling lead requires significantly less energy than producing it from raw ore, contributing to a smaller carbon footprint. Therefore, recycling lead is not just a good practice, it's a necessity. Giving lead a second life. Recycling processes. Recycling lead is a surprisingly efficient process. The journey begins at specialized recycling facilities equipped with state-of-the-art machinery designed to handle the complexities of lead recycling. These facilities are not only efficient but also adhere to strict environmental regulations to ensure that the recycling process is safe and sustainable. Used lead-acid batteries, for example, have a recycling rate of over 99%. This high rate is achieved through meticulous collection and sorting processes. These batteries are gathered from various sources including automotive shops, recycling centers, and even households. Once collected, they are transported to recycling facilities where the real magic happens. This is higher than any other consumer product. the impressive recycling rate of lead-acid batteries sets a benchmark for other materials. It highlights the effectiveness of current recycling technologies and the importance of consumer participation in recycling programs. By understanding these statistics, we can appreciate the significant impact that recycling has on reducing waste and conserving natural resources. The recycling process involves collecting old batteries, separating the lead components, and melting them down. Workers play a crucial role in this process, ensuring that each battery is carefully dismantled. The lead components are then separated from other materials like plastic and acid. This separation is vital for the purity and quality of the recycled lead. The molten lead is then purified. This purification process involves removing any impurities that may have been mixed with the lead during its previous use. High-temperature furnaces are used to melt the lead, allowing impurities to be skimmed off the surface. The result is pure, high-quality lead ready for the next stage of recycling and cast into new ingots, which are essentially large blocks of lead. These ingots are then cooled and solidified, making them easy to handle and transport. Workers carefully monitor this casting process to ensure that each ingot meets the required standards for size and purity, ready to be used in new products. These new products can range from batteries to radiation shields and even to new construction materials. The versatility of recycled lead makes it a valuable resource in various industries, contributing to a more sustainable and circular economy. This closed-loop system ensures that lead stays in use and out of landfills. By continuously recycling lead, we minimize the need for new lead mining, which is both environmentally and economically beneficial. This system not only conserves natural resources, but also reduces the environmental impact associated with lead disposal. In essence, lead recycling is a win-win for both the environment and the economy. The future of lead sustainability and innovation. As we move towards a more sustainable future, the lead industry is evolving too. Researchers are constantly working on developing new lead alloys and manufacturing processes that are more efficient and environmentally friendly. There's also a growing focus on finding substitutes for lead in applications where its toxicity is a concern. By investing in research and innovation, we can continue to benefit from lead's unique properties while minimizing its negative impacts. Our shared responsibility: using and recycling lead wisely. Lead's journey from mine to recycled product is a complex one, with both benefits and challenges. Extracting lead from the earth involves significant environmental impact, including habitat destruction and pollution. However, lead is a valuable resource used in many essential products, such as batteries, radiation shielding, and certain types of glass. The key to mitigating its negative effects lies in responsible usage and effective recycling. As consumers, we have a responsibility to use lead-containing products responsibly and dispose of them properly. This means being aware of the products we purchase and ensuring they are used to their full potential before disposal. Lead-acid batteries, for example, are widely used in vehicles and backup power systems. When these batteries reach the end of their life, they must be taken to designated recycling centers to prevent lead from contaminating the environment. By supporting recycling programs and choosing sustainable options, we can all contribute to closing the loop on lead and ensuring a healthier planet for generations to come. Participating in community recycling initiatives not only helps reduce waste, but also promotes awareness about the importance of recycling. Additionally, opting for products made from recycled materials can significantly reduce the demand for new lead extraction, thereby lessening the environmental footprint. Remember, every little action counts when it comes to protecting our environment and ourselves. Simple steps like educating ourselves about the products we use, supporting policies that promote recycling, and encouraging others to do the same can make a big difference. Together, we can create a sustainable future where lead is used wisely and recycled efficiently, ensuring that its benefits are maximized while its environmental impact is minimized.